everyone. Thank you for your attendance on our short presentation on optimizing fraud detection and how we use AI to work with the logic in compliance. My name is Mateusz Wujec. I am a data engineer in compliance reporting team, and today I will co-host this presentation with Jacek Cieslak, who is a Apex service manager, and Robert Marek, who is an Apex engineer. And at Raiffeisen Tech, our main responsibility is supporting the process of digitalization and automation of banking operations. And among those, there is a topic of compliance. And today we would like to talk a little bit more about our recent work. And to put things into more structure, first I'm going to talk a bit on transaction flagging, why it matters, why we need it, and how we come up with architecture and the solution for effective flagging. Then Robert will talk about the problems with business knowledge and its vast amounts. And at the end, Jacek will talk a bit more about how we use AI, and we'll show you a quick demo on that topic. So to start with, everyday banking systems manage millions of transactions, right? And most of them is totally legal, like sending money to your friends, payments, credits, everyday purchases. It's all fine. However, a very, very small subset of those transactions is not so legal. So money laundering, financial crimes institutions, and things like terrorism financing are still a big threat to current banking system. And at Raiffeisen Tech, we take this very seriously. So we started working on implementing some logic that would flag the transactions which seem a bit suspicious. And fortunately, we as data engineers are not required to have this vast amount of knowledge on which checks should be performed, how they should work. However, with our compliance colleagues and guys from anti-money laundering, which are a bit more knowledgeable than us, we were able to create solutions which are flagging transactions in real time and are providing the data for ex-post analysis for compliance users, which are not so super technical. So the questions that start arise: how do we process millions of transactions every day? How do we make this instantly? And how do we make this data available at all the time? How do we present it? And how the architecture should look like. But going back to the transaction flagging, there are few flags that we would like to talk about a bit more about as an example of what we might do. And first one would be flagging crypto-related transactions, because as you all probably know, because of how blockchain is constructed, it is nearly impossible to trace how the money is flowing, right? And we all know that crypto-related transactions might sometimes be not so legal, and I'm talking about tax avoidance here specifically. And while we are not able to trace how the money is flowing inside, we are able to see when the money is flowing into or out of crypto-related platforms that allow you to trade. So essentially how it works, like we have a list of crypto-related platforms, and every time a transaction is being made from or to one of those platforms, we are able to identify it and flag it as potentially dangerous. And this is being flagged for further checks by our compliance colleagues. Another example would be identifying high-risk countries. So we have our own list of countries that we consider to be high risk. And so, which basically means that there is a high probability that the transaction that is being made is maybe connected with crime, maybe connected with terrorism financing. And we definitely want to look into this in the future and to flag it. Another example, and the last one for today, would be offshore lookup. Offshore countries have usually more loose taxing than homeland countries. And some companies often move there for those purposes. And unfortunately, history has proven that sometimes they do it for the purposes of tax avoidance and not paying everything that they owe. So we as well here have some sort of lookups that allow us to check how the money is flowing and whether this is completely legit. Yeah, and of course, we are not going to talk about each and every flag that we are creating, so partially so that you don't try to find any loophole here. But the point is we are checking a lot at the same time. And as I just said, the question starts to rise. How do we process this data? How do we make this available? How do we enable our business users to analyze this and analyze our current flagging processes? And the answer here was Apache Flink. So if some of you maybe don't know, Apache Flink is a platform that allows users to process real-time data and perform some kind of data transformations on the fly. And because we are using Apache Pulsar as our main source of streaming data, and we hold here every data that can be streamed, we decided that Pulsar and Apache Flink would be a solution here. So as you can see, we have multiple topics in Apache Pulsar related to customer-related information. We have some account specifics and some information about taxing and about transactions. So everything is lying in its own Apache Pulsar topic. And all of these are then used in a transaction flagging service, which is, again, FlinkJob. And inside of it, we are joining all the data, making some transformations, and preparing the flags that I've just shown you, among others, of course. And in order to enable end users to see this data, not in the stream, because probably not so happy, we have decided to incorporate Apex, which is our instance of Databricks. And the output of transaction flagging service is one big topic in Pulsar that has all the flags, all the data is already kind of modeled. And we sync into that topic, which is then being consumed by Databricks. And the data lies in bronze layer, where it is later being picked up by some of the workflows that we have already created, where the data is being cleaned, modeled, and then a beautiful business model is being created that at the very end feeds some of the Power BI dashboards that our guys from compliance and anti-money laundering team can use to assess whether the checks that we have implemented are sufficient, how they are performing, and whether any modifications are needed. But to understand how the checks work and how to develop this, as I said, we need knowledge. And In compliance, this is kind of tough because you have documents on documents of specifications, and it's really easy to get lost in the process. So there is a problem with the knowledge gap, and the knowledge gap is a topic that will be covered by Robert.
Thank you so much, Mateusz. So I'm Robert, I'm Apex engineer. Apex not in the sense as Apex Predator. It's basically a fancy way to say that I'm somewhere between DevOps and cloud engineer, specifically for the Apex platform. So we heard about the transaction flagging process, right? And this is multi-compound problem. This is multifaceted problem, which requires quite a lot of knowledge. It requires both domain knowledge, right, and the technical knowledge. And what's even worse, it requires technical knowledge from two products inside of the company that are created by two separate teams, which you probably know what it could mean. Basically, we all would like to imagine ourselves like these perfect engineers that really know what goes where and understand everything, right? The engineer that only hears the specific subsystem existing in the company and knows where to use it. The engineer that can basically offer the architecture and solution immediately. But reality is a little more like that, right? We know some of the knowledge. We have some reference in our head about some specific acronym used in the meeting. We know that some of our colleagues worked with that specific subsystem. If it's Gert, we are lucky, because Gert is very nice. If it's Andrzej, we are not so lucky. Nobody wants to speak with Andrzej. So because of that, when we hear a lot of acronyms during the meeting, the architecture meeting, we immediately go to our knowledge base. And let's be real, it is Confluence, right? But the knowledge base. And this is our dream. We go to that knowledge base, we search for the article, and after, I don't know, 1 hour, 2 hour research, we are able to start developing. Right. Reality is a little more confusing. We usually look for the article and we are finding something that we think that is related to the actual thing, supposedly, but it is created by the other developer, which has some siloed technical knowledge and is referencing other system that we do not nothing about. So we look for that systems. And the knowledge articles about that systems also contain references to other subsystems that we don't know. It repeats itself. It's kind of like Sisyphus, right? So in the Raiffeisen Tech, we think that we found a solution for that problem. We found the usage for AI a little better than generating Ghibli-style art. So about that, Jacek will tell you a little bit more.
Thank you very much, Robert. Yes, as you all know, we have this hype for AI currently. And so we figured out that we'd like to use this as well for this knowledge problem regarding the Confluence. So as you can see, we created our task, basically a job workflow on Databricks platform, which we use. And what it is basically underneath, it's a Confluence crawler. It's a Python module, basically using a REST API to reach and retrieve the data itself. And what we retrieve actually is location of the tree where the HTML files basically are located. We pull the information from the HTML, basically body, only plain text. We don't need anything more. And then once we have this information, we use vector object. Basically, we convert the text to basically vectors. We use then once we have this, we push this to our vector store index. Basically, it's llama index, and Once we have this knowledge information, right, from which we can pull information, then we proceed to the next task. But this one basically runs once in a while, basically when you have information, additional information which comes once in a while when somebody updates the Confluence page or the structure of the Confluence, right, which we pull from. So we go then to the next job, which is running in a scheduler, right, because we need to have the chatbot running constantly during the day, and users need to use it, right? So what we use basically is Teams, which is connected to our Databricks cluster. And what happens underneath is basically a user talking like they would talk to anybody else, and they start a conversation. They put some question or whatever information they desire, and then this information moves on forward through our query engine. It's basically underneath its embedding, which we use Ada 2, basically on a model of OpenAI. Then once we have embedding, we go through the vector. And once the vector is there, we can start searching through the knowledge base that we created just before. And we try to find the best fits, basically approximation of the information that is in the knowledge base that will be the closest match to the information that we are searching for, right? So once we have this information, we then move forward to get through our system prompt. What it is, basically it's like a skeleton, right? We need to treat our model or the output of the model through behavioral skeleton. We describe how the tone of the output should be, what information can be outputted or cannot. For example, in our case, it's when the knowledge base doesn't possess the information, we can have output, I'm sorry, I don't have this information, but I got some other information for you. Maybe you would like to see this page with frequently asked questions, or maybe you would like to reach this team or the other location in the Confluence site, which might guide you to your solution, right? But, and once we got the output, it actually might look something like this, because we provide a little bit of teaser for you. We got some demo. This is just a screenshot, how it looks like. But as you can see, it's a simple information, a simple chat, which you can strike a conversation with, right? So let's take a look how it looks like in real life. And what you can see, basically, you've got some welcome messages, and it provides you a little bit of guidance what you can do with this solution. But when we strike a conversation, right, we can try to reach a compliance policy, right? And what we will get, we get some output from the knowledge base, which was acquired. But what is great, we could also get information about from where this information was retrieved. So we can, if we want, we can dig deeper and try to find it and maybe get something more, right? And for a treat for you, we got something more, a little bit of haiku from our chatbot.
Whiskers on the brow, fleeing streams dance in feline grace. Data purse with joy. That's all we have for you today. Thank you very much. Yeah. If you have any questions, yeah, we will be happy to answer. But I don't know if we have any time for.
Yeah, we have time.
Yeah. Okay.
Hi. Thanks for sharing. We happen to also have playing around with our chatbot internally and so on. Would you like to share some insights in terms of how much users are actually adopting to it? So basically, what's the percentage of the users super happy about this, you know, promoters, and versus people that like, oh, okay, thanks, nice toy, but I just like old way of searching?
I will be like fully honest. It's going slowly as for now, but people are slowly starting to adapt that, but are generally happy. We have quite a good feedback about that, but truth is mostly the dev teams right now, mostly power users at the moment, and it's hard to push it. Yeah.
I think for us actually, because we use it as well, it's a great source of finding quick information. As you know, Confluence sometimes is a huge knowledge base, but it grows and it gets fat, and it's really hard to find. And the search engine in the Confluence, I wouldn't say is the best. And everybody's wasting time trying to find something that would be useful, and you need to jump around, try to find the right workspace, try to, let's say, aggregate the information, right? And this, as you can see, can aggregate the information. It will pull the right information from which you're looking, but you can also find it through the links, right? So maybe instead of you searching yourself, you can get it much quicker, right? And I think I use it as well, so I think it's great. And as you know, everything needs to evolve. So maybe next time a new version will come, yeah?
Yeah, we have a very similar experience also. Did you have a chance maybe to look into kind of data quality before you can pull information from Confluence? Did you kind of, I don't know, pages owners, did you chase them for, hey, listen, we're going to pull information from you. Make sure that it's, polished a little. Did you have a chance to play around with this task as well, or you just thought, okay?
Not yet. We decided that it's better to have something than nothing, basically, because otherwise it will rise to such a big task that it's better to fail faster and to create something that works than to basically aggregate it to the scope that we will need to go to the higher levels to get any agreement on that. So this is why we decided to go with it as this right now. But yeah, in the future, of course, as this vector database base is vector search basically, so it's not so much work to redo the vector accumulation basically.
Cool. Thank you so much.
Hey, I'm super interested in your use of Flink to your use case. Can you tell more about like how do you find it applied to the use case that you have at hand, and maybe yeah.
So initially for this, we tried to use Apache Pulsar functions. So this is the only comparison that I have, unfortunately. And yeah, it is. We can see that Flink is really managing to pull the workloads, because with Apache Pulsar functions, we had this problem that, okay, the data is getting there, but as we introduced more and more flags, the latency became unbearable. So at some point between the transaction coming in and coming out of the flagging system, there was like 50 seconds of delay, which to us was kind of unacceptable. So in that regards, Apache Flink serves pretty well. Yeah, at some point we tried to use maybe Databricks, but it was much more hassle with the configurations, so that it's really like real time. So Apache here fitted our use case the best.